This conference will now be recorded.
Yes, class, good morning. In the yesterday class, we have discussed about the hard links and the soft link and other few things about the Linux, like inode structures, few other topics which I'd like to discuss about the mounting and unmounting in Linux. So the main objective is to identify the structures and the types of devices, some devices which are not attached by default. So we have to attach some devices. For example, your parent file system automatically attached. When you start the Linux shell or Linux kernel, it automatically attached. But some devices are not attached. So you will find some devices like, for example, your floppy drives, your CD-ROMs, they are not attached directly to the your parent file system. So to attach manually those devices, we required manually mounting. Mounting means attaching something, connecting something. Fine. And you find that devices in your /dev folder. That is called your device directory, in which you find the devices which you can attach manually and detach by unmounting. So mounting is a command to attach, to connect anything manually, and unmounting is to detach. Every file system, there are common types of file systems and their features. Mounting and unmounting of floppy drives to a Linux directory tree. You have a parent tree structure in which you want to attach your these systems like floppy disks, your CD-ROMs to and from the Linux directory tree. And you have to create a disk partitions also. So mounting is nothing but connecting a file system to the existing hierarchy. For example, this is your existing hierarchy. This is your parent. This is your root. You want to attach, fine. And there are folders. These are the folders which are automatically attached, fine. Now you want to attach few devices to that root. For that one, you require a mounting. For example, unmounting is disconnect. That is which was mounting. Example, for example, two partitions. You have Dave devices. Fine. This is the folder. Fine. In which you have hard drives. For example, partitions are there. Two partitions are there, primary and secondary, or you can say master or a slave. These are all your hard drives. Fine. HDA1, HDA0, HD2. So these are all your hard drive partitions. So that is your, one is your master, one is your slave, one is your secondary. You will get notations HDA0 like this one. You want to attach similarly hard drive 1, hard drive 2, and so on. Similarly, for example, Windows. Fine, you want to attach this one, and this is for your networking file system. NTF stands for your fat file system of Windows. You want to attach. Fine. Similarly, you want to attach one hard drive to ext3 file system. Fine. So you can mount it upon this. So these are your hard drives, one for your Windows, one for your ext. So you want to attach that one. And the command you can use is mount. Fine. This T stands for the type of device you want to attach. So type of device is your NTFS. Fine. Devices where to mount it. Fine. So this is the source and this is your destination, you can say. This is your source. For example, you want to go for this and you want to mount at this point. So this is my source and you want to take this drive and you want to take the devices. Devices are here lying in this folder and you want to mount. Where you want to mount, you can put the destination here. So I want you mounted. There is by default one folder already created in your parent directory, and that is your MNT mount. You can mount these devices by, this is your root. So root have the MNT and you can mount these devices to this root directory and it has a folder MNT. So this T stands for your type. This is your device. Fine. And you can mount. So one is your type. This is your type. This is your device. and this is your directory where you want to mount. So all these files in a Linux file systems are all arranged in a big tree rooted as the slash. These files can spread out on various devices based on your partition table. Initially, your parent directory is mounted. Your parent directory is already mounted, attached to this tree. Others can be mounted manually using the GUI interface or using the mount command. Mount command is used to mount the file systems found on a big tree rooted, and unmount to detach these devices. You can detach these devices from the tree itself. Fine. So mounting Unix system requesting a removable device that can be added to your root or a file hierarchy. So you can requesting any removable device that can be added to your file directory. Root directory of the mounted system will be treated as a subdirectory in the base hierarchy. Mounted files can be used as a part of the file system on the system boot disk. So you can write this one like mount, your type of device and where you want to attach it. So mounting is your source, this is your source and this is your destination. You want to take this device, it is lying there, CD-ROM, and you want to attach in a folder called CD, media, CD-ROM. So it will attach to this one. Unmounting a device from the base hierarchy, you can remove CD-ROM by unmounting. So root file system, when a file system, Linux file system is first turned on, file system on a hard drive is mounted to your directory. Automatically, few files are all automatically mounted by the system itself. So they have been attached. So file system on the hard drive is mounted to your root. It contains most of your operating system files. Mount command is used to mount devices to mount directories. When used with no option arguments, lists currently mounted file systems. And unmount is used to unmount devices from the mount point directories. Same MNT folders is there, and you can use the unmount to detach that from the MNT folder. And similarly, you can attach to the mounted folder. So one is your mounted MNT folder, you can attach the devices, and similarly you can detach from that mount folder directories. For example, these are the few commands I told you about. This one, mount, it will display the mounted file system. If you write only mount, it will display all the mounted file systems which you have attached manually. And if you want to attach something, then you go for T. It has other options like L for listing, for H for displaying, for V for the version, then T for the type of file system, capital T, other read for the route. For example, R option is there to read only mounted. So this is your type, this is your device, and this is your mount point. Fine. You want to mount a device of a certain type to a mount point. Mounting point is your MNT folder in your root directory. So that is your mounting directory. F user is also used with option U, and the directory to display the user with a particular directory. So this is a command. Similarly, unmounting a device from its mount point, then you use the unmount and the mounting point. Like for example, the folder path, like slash your CD-ROM slash your floppy, whatever, or either you mention the device name or either you mention the mounting point. So mounting point with the full path, that means you can give here. So unmounting means you can give the mount point or you give the device name. It will detach from your mount point and return back to your Dave directory or a Dave folder. Fine. So Windows, like same partitions are there. Windows have disk 1, disk 2. Linux has devices SDA1, SD0, that is for secondary hard drive, master hard drive, SD0, SD1. File system in Windows has networking file system or a FAT file system 32. It has ext3, ext4. Fine. Mounting parameters, like mounting, it has, you can mount to D drive, E drive, C drive. It has a mounting point. MNT folder in a root directory. This folder where OS is stored is your C drive. Here it is the root. So this is a root where mounting take place and consists of your parent tree structure. And here the mounting point is there. I told you about this one. That MNT folder is there. So this is your mounting. Root has a mounting point and that is a mounting folder, MNT folder. And here are the devices. Similarly, devices are also there. If I get back to few things, I have shown you this one. I think like this one I've shown you the folders, the parent hierarchy. Like these are the, it has a root, has one of the dev, that is your device files. Fine, it has everything. Similarly, it has the MNT mounting files for a temporary file systems. So you want to attach something temporary, like for example your CD-ROM, your floppy, your drives. So MNT, this is the mounting point, and this is your devices. So you can directly take the devices and mount here. It's all lies in your root. So this is your root, and root has the basic first. Fine, and one of the folders is your MNT folder for mounting, and one of the folders to take the devices which are temporarily attached and detached from your parent directory that lies in your dev or device folder. Fine, so these are your mounting and unmounting. Fine, this is the hierarchy. Like for example, root is there, data, etc folder, home directory. It has further subdirectories, and mounting. You have mount the floppy and your CD. So this is your mounting, and they all lie in your Dev folder. So Dev folder is nothing but your temporary line. Their devices are like there. You can attach to your MNT folder. Now the floppy drive is usable to use in Linux. Similarly, CD-ROM. If you want to detach from this main file system, you can use the unmount command. Fine. So this is about the mounting. So it will display all the information. It has various other options also. So this is the mounting and unmounting. So the next topic we have to discuss is journalism. So the next topic is journalism. Journalism is basically a journalism is a file system that keeps the tracks of the changes that will be made in a journal, usually a circular log in a dedicated area of the file system before committing them to the main file system. Now journalism is nothing but it is a file system that keeps the tracks of changes. Before you made anything to the main file system, you want to correct some changes, you want to do some updation, you can do the changes in a log, in a, you can say, a temporary file system. That is called as your journalism or journaling file system that keeps the track of changes. You can maintain a log, do one-time updations or what changes you want to do, and then finally correct them to your main file system. Fine. So journalism is a file system that maintains a special file. It maintains a special file called a journal. That special file is called a journal that is used to repair, you can say, repair any inconsistency that occurs as a result of improper shutdown of a system or any kind of error. Any kind of error. It can be a system crash, it can be a power outage. So journal or a log, this log is called as journal. So journalism file system, it keeps a journal or a log of the changes that to be made, what changes to be made in the main file system during the disk writing, or you can say any corruption or any reconstruction that to be occur while the system is in moving or executing. So you want to keep a log what all corrections to be done in your mail file system. For that one, journalism is there, and a file that he maintains journalism is your journal. Fine. So it is a log file generally. In the event of system crash or a power failure, such file systems are quicker to bring back online a stable state and less likely to become corrected. So in the case of system crash or any default situation or any power failure, it will return back what all to be done to keep the track and return back the original version of your system and less likely to be corrupted. So journalism provides you fast and effective recovery. Actually, basically the recovery technique in the case of disk crashes, like for example, any disk, any or disk can be crashed using the commands. So these are the commands FSCAK, and these are the commands which can be used. So basically it is a recovery commands. So these are the commands which are repairing your file system. File system check. So this is your file system check commands actually for ext2, for ext3, everything we have the file system check commands are there. So these are all your recovery commands. It's a command utility that allows you to perform a consistency check and interactive repairs on one or more Linux file systems. It uses the program specific to the type of file system. Specific file system, for example, ET2 is there, ext2, ET3 is there, so ext3. So these are the file system checks. So these are, you can say, it's just a repairing, file system repairing commands or a command utility to perform any kind of, it's just a tool, you can say, that is used to check the consistency. Everything is going fine in a file system or not. If it something is going deliberately wrong, that this tool can be take care and will check it and repair the where it requires. So any kind of inconsistency, this file system check command can be used. Similarly, if you want to do any corrections, so first you have to write the journal logs. One is the journal area and one is your file system area. So if you want to write something, you can write on a journal log. Fine. Then you make the changes to the actual file system, and after that you delete the journal log. So all the things to be done in one go, you first maintain a log, write everything what has to be corrected in your main file system, and then in one go you go for the file system corrections or any kind of repairing or any kind of changes, and after that you delete that journal log. Fine. So writing, then make the changes to respective your file system, and after that delete your. Fine. So Linux journaling file system, if non-journaling file system is improperly, for example, if you're not doing anything like this stuff and your system improperly shut down, then operating system detects this and check the performance by utility. For example, if you are not doing non-journaling and your file system will improperly shut down, then all the things you have to do by utility called FSCK, that is your file system check. So you have to use this tool or you have to use this command utility to do it manually if non-journaling file system is not there. If it's not maintaining any log file to repair your file system. This file system FCH scans the whole PC. It takes more time and fixed any issue that can be safely corrected. So in this time, some corruption of data will happen. So it will scan all the system and do the rectification for you. Maybe it can able to corrupt your data or maybe not able to sort out your problems. So better to do journaling rather than the FCK. To prevent this journaling file system was created. To prevent this kind of data, FCK is one of the option, manual or utility tool option to repair the system, but journaling is far more better than your FSCK. Fine. If the crash occurs, journal can be used as a checkpoint to record the unsafe information and avoid corrupting file system metadata. So in a crash case, journal can be used as a checkpoint to record your any unsafe information and avoid corrupting your file system metadata. So it's better to have journaling rather than the scan check for the disk. So there are three journaling modes. There are three journaling modes, and first one is your journal. All file system data and metadata changes are logged into a journal. That is the safest but slowest. Then one is a ext3 file system. It has a default that is called your ordered. Only changes to the file system metadata are logged into the journal. Data blocks are written to the disk before the data. It will do for all your everything. What is keep on changing, it will keep a maintain of log, but it will only keep the changes to the file metadata, not the data. It will maintain both the data and metadata, but ordered in ext3, which is by default journaling mode, it will maintain only metadata. That will changes done in the metadata to be logged in the journal. Data blocks are directly written to your disk, fine, before the metadata. So it will not maintain any corruption or any mishappening done to the data. So it will only take care of your metadata. Write back is one of the also journaling mode. Only changes to the files and metadata are logged, not the data. So it will only maintain the metadata, and that is the fastest because it will only take care of metadata. It will take care of metadata and will write your data blocks on the disk. So it has one copy of the data block, but it is not doing anything with your data. So it is not handling your data, it is only handling your metadata, whereas journal is maintaining both your data and metadata. So these are the three journal modes. Fine. So journaling is generally a part of ext3 file system. So that is the advantage of ext3 over ext2, which improves the reliability because ext3 has journalism. So it will have improved the reliability and eliminates ext3 eliminates the needs to check the file system after unclean shutdown. For example, if the cleaning of shutdown will not take place, yeah, your shutdown system crashes abruptly, then you require the journalism at the most to recover your last save information or last done information. Fine. So journalism is inconsistency occur when the file system is unmounted, when application is being updated or FS metadata is being updated. Any inconsistency can be recorded in your journalism and can be rectified by this. Journalism keeps the track of the changes about made in the file system before the actual changes made. Journal made use of time of reboot, checking the log for pending change in the file system. Different types of journalisms are there, and by default we are using in ext3 the ordered one. Fine. So reasons for using journalism: updating your file system to reflect the changes to file entries requires many separate write options. Deleting a file, removing the directory from the entry, releasing the inode number, returning all the use block to the pool of free. So these are few things. For example, you are not using any inode number, so it can release. Fine. Similarly, using all the blocks which are not used and free by your system, you're not using, so it will release. Removing its directory entry. These are the all stuffs journalism will do. Or it will release your memory which is not used by you right now, or it been already been used by you in the earlier program, so it will remove. So to prevent this, journalism file allocates a special area called journal and records the changes it will make the head of time. So like for example, earlier what happened, it fck command will to delete all the files, like removing this, remove inodes. So system will remove all these and delete the file which is unused. But journalism will maintain a record. It will maintain a record what changes to be done ahead of time so that it will be done before in your file system. So fine, so it will maintain, not doing directly. It may be asked for you, it will wait for some time by maintaining a record. And if for the later use, it is not using that file. If you're not using that file or directory or a blind, it will remove that by later course of time. Fine. So this is by updating a file system to reflect your changes. So journalism is to maintaining a backlog or to maintaining a, you can say, a standby mode so that repair can be done very peacefully and very gracefully rather than abruptly. So these are the points for journalism, journaling and how to do journaling, what is the need for journaling, and these are the points which we cover in journaling. Other things are also there, that ext4 is also maintaining, ext4 is also maintaining other journalism like fxx. I told you this one xfx silicon graphics. So ext4 is the most preferred, ext4 file system is the most preferred Linux file system, and they are using this kind of SF silicon graphics for your journalism. Fine. So journalism can be done to prevent any kind of data corruption, crashes, or any. Your system is maintaining a file or a journal to keep the track of each and everything. So journal is nothing but a log file to get through everything.